Assalamualaikum, my name is Mohamed Haikal. My ID student is 2022-454-122. I'm going to tell you about introduction. So the introduction is glassware is commonly calibrated using a liquid of non-specific density and an analytical balance. Essentially, calibration involves comparing the measurements obtained from a specific piece of glassware with non-reference values. This comparison allows scientists to determine any deviation or inaccuracies in the measurement made by the glassware. Volumetric glassware refers to various types of laboratory equipment designed for precise measurement and dispensing of liquids.
Assalamualaikum and hi, my name is Puteri Balqis. I'm going to explain about advantage of a volumetric glassware. Okay, we have 3 points for advantage. The first one is many size available, easy to cleanse. Okay, the ability of volumetric glassware in many size and its ease of cleaning contributes significantly to its utility and effectiveness in a variety of laboratory applications. Second is suitable for chemical and reagent storage. The features make volumetric glassware a reliable and practical choice for storing chemical and reagent in laboratory settings. The third is pyric resilience to heat. Okay, due to its borosilicate compositions, make it an excellent choice for both laboratory and kitchen use, providing safety, durability, and versatility in high temperature applications. That's all for me. Thank you. Bye.
Next, the disadvantage of volumetric glassware. It is relatively expensive. It will shatter on breaking. Then mistakes in reading the meniscus or handling the glassware can lead to inaccurate measurements. Next, application of volumetric glassware. Volumetric glassware has superior thermal and chemical resistance and is better suited to glassware for storage of solutions, for example volumetric flask. Volumetric glassware in analytical chemistry for preparing standard solutions, titrations, and accurate measurements of reagents and samples. In medical laboratories and pharmaceutical industries, volumetric glassware is used to measure precise amounts of drugs, reagents, and solutions for medical diagnostics, drug formulations, and quality control.
Assalamualaikum, my name is Nadhirah and now I want to talk about types of volumetric glassware. So firstly, we have graduated cylinder. Graduated cylinder is used to measure and dispense known volumes of liquids. They are manufactured to contain the measured volume with an error of 0.5% to 1%. For 100 ml of graduated cylinder, this would be an error of 0.5 to 1.0 ml. Measurements made with a graduated cylinder can be reported to 3 significant figures. And secondly, we have volumetric flask. With capacities ranging from 1 ml to 2 liter, the volumetric flask is intended to hold a precise amount of liquid, typically within a tolerance of a few hundredths of a milliliter or roughly 0.1% of the flask capacity. A calibration line is carved on the thin neck portion of the flask. The bottom of the meniscus is on this edge line since it is filled with liquid. The calibration line is unique to a particular flask. A group of flasks constructed to hold an identical volume will have lines positioned differently. And thirdly, we have burettes. A burette is a long, narrow tube with a stopcock at its base. It is employed to precisely dispense varying quantities of solutions or liquids, with a 0.00 ml mark at the top and the 50.00 ml mark in the bottom. It is graded in 0.1 ml increments. Observe that the marks stop short of the stopcock. Thus, the real capacity of the burette to store solution is greater than 50.00 ml. There are also burettes available with liquid capacities of 10.00 ml and 25.00 ml. And for the fourth one and the last one, we have pipettes. Pipettes are designed to deliver a known volume of liquid. Their volumes range from less than 1 ml to about 100 ml. There are several types which vary in accuracy and in the type of task for which they are optimum. So first, we have volumetric pipettes, and secondly, we have more pipettes, and lastly, we have serological pipettes.
Next, I'm going to explain about use of volumetric glassware in industry. We have 3 points for use of volumetric glassware in industry. The first one is food and beverage. Okay, in nutritional analysis, sample of food and drink are measured and analyzed for nutrient content using volumetric glassware. In quality testing, pipette and graduated cylinder are useful tools for testing for impurities, granting product safety and adherence to legal requirements. Second is pharmaceuticals. In drug formulation, precise solutions are made in volumetric flasks for drug formulations. In quality control, titration and other analytical procedures use pipette and burette to guarantee the concentration and quality of pharmaceuticals. The third is is chemical industry. Okay, in reagent preparation, chemical reagents are precisely prepared and diluted using volumetric flasks and graduated cylinder. In analytical chemistry, titration and other quantitative analytical method that ascertain a chemical substance concentration depends heavily on pipette and burette. That's all for me. Thank you. Bye.
So for the methodology, there is 4. First, weighing the empty glassware. Second, adding distilled water. Third, measuring temperature. And last, calculating the volume. So first, we're going to weighing the empty glassware. Weighing the empty glassware, start by weighing the dry empty glassware such as volumetric flasks using a calibrated balance. For second, adding distilled water. Place the required amount of distilled water in a beaker. Then, measuring the temperature. Record the observed temperature of the water before pouring it into volumetric flask. And last, calculating volume. The mass of water, M, is determined by subtracting the empty flask weight of the flask filled with water.
Hi, Assalamualaikum. My name is Syaayuni, Syahirah Binti Mohamed Zabri from AS1204A. The topic I want to present is example result for burette. Calibration mark of burette will be located between 0.00 milliliter or the maximum capacity line. It depends a portion of deionized water from the burette into the beaker. The portion size depends on the size of the burette. For 5 ml is 25 ml burette or 10 ml for 50 ml burette. And you need to determine the mass of water dispensed using the analytical balance. For get the right volume, you have to repeat step the IC layer until the 25 ml or 50 ml, depending on the size of burette that mark has been reached. For each total volume of water dispensed, you need to record the total mass. And it can discard the water in the beaker and refill the burette to the 0.0 ml and repeat the step from a layer until the latest 2 more times for a total of 3 calibrations. And you should not try to dispense exactly the same volume of liquid. For each set of calibration data, it determines the volume of water dispensed by dividing the total mass of water by the density of water at that temperature. When you have finished its calibration, it should have a data set similar that shown below, that for indicate volume for burette in milliliter. For first is 5.32. For second, 9.97. And second, the last one is 15.06. And for mass of water dispensed in gram, shown that first 5.2993, second 10.0038, and the last one 15.007. For calculated volume of water in milliliter is 5.3009, second 10.0068, and the last one 15.0072. Is shown that the difference in volumes by subtraction the calculated volume of water from the indicated volume of water. In that table above, we have a calculated volume of 5.3009 milliliter and indicate volume of 5.32 milliliter. For performing the subtraction, we see that the difference is 0.0191 milliliter. The difference can be either positive or negative, so do not ignore the sign.
So, in summary, calibration is done to ensure repeatability, uniformity, and accuracy in measurements so that results and standards can be trusted. Inaccurate readings, out-of-spec results, and risk to equipment longevity and safety can all occur from improper calibration equipment. Bye!